So the fragile base class problem is a software design issue that arises in object-oriented programming when changes made to a base class can inadvertently break the functionality of derived classes. This problem occurs due to the tight coupling between base and derived classes in inheritance hierarchies. So let's now have a look at what are the issues caused by the fragile base class problem, and then we'll look into why we should probably use, generally you should probably reach for composition over inheritance for most of your solutions. So let's first of all consider a simple example. So let's say we have a shape class, which is our base class, and let's say we have lots of different derived classes or subclasses which are going to be actual shapes, such as a square, rectangle, circle, triangle, etc. Okay, so our shape class is our base class, and then we have lots of different derived classes. So first of all, one of the issues with using inheritance or having a fragile base class, not necessarily inheritance, but having a fragile base class, is inheritance coupling. So inheritance creates a strong coupling between the base class or the superclass and the derived classes or the subclasses. Any changes made to the base class can potentially affect the behavior of all derived classes. So if we change our shape class in our example, it could affect the behavior of all of our derived shape classes. Okay, so another issue is limited extensibility. So the fragile base class problem limits the extensibility of software systems, as modifications made to the base class can become increasingly risky and costly over time. Developers may avoid making necessary changes due to the fear of breaking existing functionality. And this is kind of known as brittle software, where making a change to one part of the program can cause all sorts of different parts of the program to break, making it brittle. So this is kind of, if we have like a base class where we have hundreds of different subclasses or derived classes, then you can kind of see that making changes to this base class becomes very risky, because it could have an effect on so many different derived subclasses, and it could cause all sorts of issues, and it can break a lot of the existing functionality. And this is very much a good example of having a fragile base class, where we have lots of derived classes over time, and making changes to this base class becomes very risky. So how can we mitigate or prevent having a fragile base class in our software? So to mitigate the fragile base class problem, software developers can use design principles such as the solid open-closed principle, and they can also use the dependency inversion principle, as well as using composition over inheritance. And these approaches promote loose coupling, encapsulation, and modular design, reducing the impact of changes in base classes. So generally, it's often recommended to use composition over inheritance. And the reason for this is because composition results in less coupling and more flexibility. And it's also easier to build classes out of various components than it is to try and find commonality between them and build a family tree, as you kind of have to do with inheritance. So there are still cases where inheritance makes more sense, but generally it's recommended to reach for composition more so than inheritance due to those reasons.